Very good morning to one and all. Welcome back for our day two of Atal sponsored 1 week faculty development program on cyber security analytics. Now I take privilege to introduce Dr. Devasi Samantha to the participants. Professor Samantha sir received his BTech from Science College, Calcutta University, MTech from Jadavar University, Kolkata, gold medalist, and PhD from IIT Kharagpur in Computer Science and Engineering Department. Currently, sir is an associate professor in the Department of Computer Science and Engineering, IIT Kharagpur. Professor Samantha is actively working in the field of human-computer interaction and cyber physical security. He has developed efficient interaction mechanisms for people with special needs, such as motor impaired people and people with other disabilities, illiterate people, etc. Further, he has developed a multimodal interaction technique, text entry mechanisms in Indian languages, which are new of their kind to bridge the digital divide. Currently, he is working toward the development of next generation hands free and touch free interaction mechanisms using brain computer interfaces. He and his research team are in the process of developing BCI HCA lab in IIT Kharagpur, a unique lab facility in India. He is an author of 3 books and more than 80 journals and 120 conference papers of international repute. He is currently an honorary member of the editorial board of the International Journal of Biosciences and Technology USA and a member of editorial board of the International Journal of Communication Networks and Distributed Systems UK. He is the recipient of Best Author of the Year award by Computer Society of India, Best Paper award by 8th ADCOM Conference, Microsoft Valued Professional Award by Microsoft USA, and author of the best-selling book by Princeton Hall of India, New Delhi. With this brief introduction, I request Samantha sir to take over the session. I request Samantha sir to take over.
Okay, just a minute. I'm just getting some network problem. I'm trying to sort it out. I'll be back within 1 minute or so. Please.
Sure, sir. Sure.
Good morning to everybody. Hope I'm audible to all of you. I just want to know whether you can hear me. Anyone
Yes, sir.
can respond?
Yes,
Yes.
sir. Yes, sir.
Okay, so I'm audible. Okay, so I will keep my video off to save the bandwidth. Actually, presently I'm in a very low bandwidth region. And okay, let me share my screen so that I can show you the slides that I'm going to use in this program. Anyone, please confirm whether you can see my slides?
Yes, sir, it's visible, sir.
Okay, okay, that's
Yes,
fine.
sir, it is visible.
Okay, that's fine. Thank you all. So, okay, fine. So, good morning to everybody. I hope you are all safe. Your family members are safe. It is really a difficult situation that we are going through. Anyway, we hope that shortly we will be able to overcome and we will be able to come to our normal life. So let's hope for the best. Okay, let's come to our business. So today, the topic that I have chosen for you, it is related to cyber security, because this FDP, the title is also cyber security. So there are certain analytics approach. Okay, but I feel that a very recent and advanced topic on cyber security will be better, so that you can be familiar to, you can be introduced to a new concept, a new direction. Now, in this presentation, I assume that my participants have certain background of security aspects, in particular the cryptographic concept. Anyway, if you don't have any background on those topics, it will not be so much affected, because you will be able to follow my delivery comfortably, I hope, because I kept the presentation in a very pedagogical manner, in a very general manner, so that people having a little bit background in maths or something like, they will be able to follow it. Okay, so the topic is crypto biosystem. This is the system that I'm going to introduce to all of you. And to develop this system, I have proposed an idea. This idea, it is a biometric based idea, and it has immense application in the field of cyber security. So in my today's talk, I will start with a basic concept of cryptography, and there is a essential elements, a pivotal elements in the cryptography. It is called the cryptographic keys. So I'll cover this concept first, and then I'll discuss biometric data. I'll include this discussion because I anticipate that many of you are new to this biometric data. So that is why I just want to give. So you can consider the two agendas are for the beginners. And then finally, I'll come to the core agenda, that is the crypto biosystem, which I'm going to tell you. And to develop this crypto biosystem, we will follow an advanced approach using biometric data. And finally, I'll come to the discussion of some applications of the crypto biosystems, and then future direction. Now, so the topic that I'm going to discuss, it is a result of a rigorous research, and definitely the security framework or the security concept, is a mathematically rigor, and too much technical things are there. And the concept that I'm going to present is a 4 years product. So you can understand that so many things are there in details, which is not possible to cover in 2 hours presentation. But anyway, I'll try to give you the basic essence without losing the main concept. It is there. So that is the challenge for me, of course. And in case if you have any problem or any query, you can interrupt me either during my delivery or at the end of this discussion. So let's start about the concept that I'm going to discuss first is a cryptography and cryptographic keys. So this is the essential things. As you know, cryptography is not a new concept. It's a very old concept. Even in the primitive era, when the human just transiting to the civilization or like that, they wanted to keep secret many things. They wanted to communicate in a secret manner like this one. So whenever security come into the question, then people think about cryptography to use that. Particularly these cryptography concepts immensely popular uh, uh, in the World War I. So that time there was a huge need to communicate many information among the different what is called the stakeholders. So that is why they propose many cryptographic aspects. So it is a little bit history of cryptography, and down the line, so cryptography as on today, it's a very advanced one field. Many research have been initiated, many results have been, and we use today in today's society, it is called the ICT society, information communication technology, where we cannot think the success story of this ICT without the cryptography there. Even when you are using internet or a computer, you are eventually using the cryptography and security there. Now, what exactly we are doing with this cryptography? So, cryptography is about authentication, integrity, and non-repudiation. So, authentication means if you want to send a message to your peer, then you should use the crypto system for that. Why? This is because the message that you have meant, it is only meant for authorized receiver, authorized recipient. No third party which are not authorized to access this message will be debarred from this communication. So this is the authentication. And the integrity, what is the idea of the integrity? The integrity is that whenever you want to share a message through an insecure channel, usually we want to send some data through a network. That may be public network, even the private network, whatever be. So through network we want to send the message. That network may be wireless, may be wired, maybe whatever it is there. So the idea is that integrity comes into that network communication where whenever you send a message, no third party should be able to change the message content. So changing the message content or corrupting the message in one way, it is violating the message communication requirement. So this is the integrity. And the non-repetition, if you know the concept of digital signature, the non-repetition is very one important criteria. So with this non-repetition criteria, the idea is that whenever a sender sends a message with his signature and then it reaches to a receiver, then receiver should understand that it is from the genuine sender, and no way sender will be able to deny the authenticity of the document that he has sent to the receiver. So that is the non-repetition. If you sign a document and if it is your sign, then you cannot deny that signature to a receiver. So this is the non-repetition. Now I have mentioned three important characteristics that is required in our cybersecurity environment, and these are the things is possible if we can follow the cryptography. So cryptography come here to ensure the authenticity, integrity, and non-repudiability. Okay, so this is the concept of cryptography. Now, in order to implement a cryptographic mechanism, one essential element, this is called the cryptographic key. Now, cryptographic key, there are two different types of cryptographic key depending on what sort of cryptographic application that you want to have, what type of cryptographic system that you want to use. So there are two types of cryptographic system. One is called symmetric cryptography. In case of symmetric cryptography, one key is used. This key, that is cryptographic key of course, this key is called public key. Now what is the idea of the public key? So suppose I want to share a message to X. Then what I do is that I will use this key to do some formalism on the message, and then I will share my key to that X so that X can use this key and then again reverse formalism that they can apply to get back the original message. So this is the concept that is used in case of symmetric cryptography. And in case of symmetric cryptography, only one cryptographic key is required, which is called the public key. And this key is called the public because before sharing a message, I want to share the key to my recipients. So this is the symmetric cryptography. On the other hand, there is another cryptographic system. It is called the asymmetric cryptography. Now, in case of asymmetric cryptography, instead of symmetric cryptography, we use two different keys. One public key, which is just like a symmetric key, it is shareable among the different stakeholders. And then there will be two specialized keys if sender and receivers are involved, and they are called private key. So private key for the sender remain private to sender, and private key to a receiver remain private to the receiver. Now, so these two keys in combination are used to develop a cryptographic system, and then message can be communicated using this two keys concept. And there are different protocols, the different strategies are there, how this asymmetric cryptographic system can be built, and many algorithms, many techniques, and many formalism are there, of course. So these are the two types of cryptographic system. Obviously, asymmetric cryptography has its own merits compared to symmetric cryptography. So mainly, whenever we consider cryptography, by default, we think that it is asymmetric cryptography. Now, whatever be the cryptography system is there, you can understand that the essential thing in the cryptographic system is keys. That is the cryptographic keys, whether it is a public key or private key. Now, the question is that how one can generate this key to be used in the cryptographic system. So cryptographic key generation is a very challenging problem because there are many things to be there. You should use the key in such a way that it is very private. No one, any third party should not be able to know your key, because this is the important thing. If the key is known, then definitely the system will be okay. So we have to maintain the highest, what is called the secrecy in the crypto key. I'm getting a lot of noise. I don't know. Could you please mute your microphone? A lot of noise are coming here. Yeah, this is fine now. Yes. So what I want to mention here, in case of any cryptographic system, whether it is symmetric or asymmetric, cryptographic keys are essential elements. So the question is that how this cryptographic key can be generated. Now, the basic things in the cryptographic key is that it should be highly secure. That means the cryptographic key should be limited to the communicating parties. Anyway, it should not be accessible to any other party. It is called the third party or any intruder. Now, so that is why cryptographic key generation is the most important and most challenging task so far building a cryptographic system is concerned. Broadly, there are two different ways to generate cryptographic key. One is called pseudo-random number generator. It is briefly called PRNG. It is a very popular technique. Many of you probably know that what exactly the PRNG it is. There are many PRNG algorithms. You can say 1,000. I should say no, it is 10,000. Even more than that, PRNG algorithms are there. Every algorithm has its own merits as well as some limitations. Now, PRNG algorithm is a totally software-oriented mechanism to generate cryptographic key. So you can write a program based on a particular PRNG algorithm so that this algorithm will generate a key for you. So whenever you need a cryptographic key, you can run your algorithm to generate your key. So that is the PRNG. That is the software oriented approach. In contrast, TRNG, it is called the True Random Number Generator. Now, TRNG totally a hardware approach. So a hardware system can be built which will produce a cryptographic key that can be plugged into your cryptographic system to use that one. Now, definitely PRNG, so far the PRNG is concerned, it is very easy, simple, and computationally not so much costly appears, quick. On the other hand, TRNG is costly because you have to build a hardware. If you want to follow the different algorithm to build the different keys, then the new hardware to be there. So this way it is not so cost effective. However, hardware approach is fast, but again plugging with the system, so many things are there. So TRNG. But TRNG, obviously, if you see that very strong and then reliable cryptographic key, if it is required, then TRNG is the most favored one technique compared to the PRNG. And another difference between the PRNG and TRNG is that PRNG, by its name, it is called the pseudo-random. That means the chance is that out of say 100 millions of cryptographic keys, the chance is that 10 or 1 will match with others. On the other hand, TRNG, it is called the true random. So even in the 100 million cryptographic key, if you build, it will produce all 100 millions are unique. So this way, definitely TRNG is most preferable. But PRNG, so far the application feasibility is concerned, PRNG is possible. So mainly if we don't bother about too much critical about the cryptographic system, then we can think for PRNG based approach only. So most of the application in cryptographic system follow the PRNG to generate cryptographic key. Anyway, so two broad ways we have discussed about PRNG and TRNG. But the approach that I'm going to discuss, it is actually a PRNG approach. It is not the TRNG, right? But we can build a hardware based on the concept, then it becomes the TRNG, provided that it is really true random number generator is there. Anyway, I will discuss this issue later on. So the concept that I have told you that so far the cryptographic key generation is concerned, we have to satisfy 3 important requirements. The 3 requirements are your cryptographic key should be strong enough. What do you mean by the strong cryptographic key? That means if you use a cryptographic key using an algorithm, say the PRNG algorithm, then the key cannot be guessed by any other party. So it will be too difficult to guess. Even the difficulty level, you can say, in order to crack a cryptographic key, you may need 30 years to run a high-speed computer. Then you can say that, yes, your cryptographic key is too strong. I can tell you, for example, you usually use for your Gmail account, login and password. Anyway, login is known to everybody. What about your password, right? So password is again another key that you use it. That is also an authentication mechanism that we follow. Now you can understand that whether the password that you use, maybe it is a 10 characters password with all numbers, uppercase, lowercase characters, special symbol, whatever you can think about it, whether they are strong or not. So truly it is not a strong, whatever the password, you can follow it, because an intelligent hacking system can be built, which is called the dictionary attack, and which will take hardly an hour to crack your password. So in that sense, it is definitely not a strong credential that you can think for your Gmail account or say any other systems to authenticate yourself. Another requirement is the non-linearity. What is the meaning of non-linearity? So the algorithm which you should follow to generate cryptography, it should not be linear. That means give an input to a function f and it will result y. So y equals to fx. So you know whether this function f is a linear function or non-linear function. So non-linear function, if you follow, then it is very complex. And as the complexity is there in the non-linearity of the function, then it will be very difficult, because the reverse way getting, so that means if you know y and then knowing y, guessing x will be easier if it is linear. On the other hand, given y and then learning x will be very difficult if you follow the non-linear functions. So non-linearity, obviously, to enforce the stronger cryptographic key. Another thing is that the cryptographic keys should be large. As I told you, again, it is also large cryptographic key so that it is difficult to guess and then more reliable and more robust. So usually in a traditional cryptographic system, we use 256 bits or 512 bits, 1024, 2048 or so. So it depends on what kind of criticality your system it is and how much strict you are in your security. Then accordingly you can decide about whether it is large or small or medium sized cryptographic key you want to use it. If you obviously follow the large cryptographic key, then your system may be slow because cryptographic key processing require a lot of computation, and then larger cryptographic key can be slower for your system to use it. So it depends on what type of is the trade-off, right? If you want to have the fast and small cryptographic key, small size cryptographic key, but there may be the chance that it can be tempered by some third party, by some intruder. On the other hand, larger cryptographic key is very robust, very reliable, but it is computationally expensive. Another criteria, it is called the random. Random means that your cryptographic key should be, for example, your password. You should select a password so that it should be as random as possible. It definitely should not be one word which is there in your dictionary or 2-3 words combining to like this one. So I'm sorry, it is not a good what is called the composition for a password. Rather, you can think about very random collection of characters, numbers, and then special symbol can be this one. Now, randomness, definitely the concept is that randomness, another advantage is that if you follow a particular algorithm and if it capable to give you the random cryptographic key, then you will be able to generate very large set of cryptographic key. Because the algorithm that you have developed, it can be used by million or billion of users, then definitely all million, billion users should have their own and unique cryptographic key. So this is the one requirement, it is there. Now these are the three essential, what is called the needs and essential criteria so that you can generate a cryptographic key. Whenever you propose some idea about generating cryptographic key, then you have to formally as well as informally. Formally means with some mathematics, informally means with reference to different attacks that is possible, to prove that all these three criteria are satisfied by your algorithm. Then only you can claim that your approach is genuine and it is useful. Okay, so this is the concept that I wanted to give you. I hope you have understood. My presentation was there to give a basic introduction to cryptography and their cryptographic key. Now I'll come to the discussion of biometric, because the approach that I'm going to discuss, it is a PRNG, but it is a new concept, it is a new direction. So it is actually PRNG algorithm will be implemented using some data which is called the biometric data. Now I'm telling you, so far the PRNG or TRNG, whatever the formalism that you follow, mechanism you follow, you need one important idea, it is called the seed. So what sort of seed you can follow, right? So the approach that I'm going to discuss with you, it is the biometric data as a seed. That means from this biometric data, we shall be able to generate a cryptographic key that can be used for the cryptographic application. Now let us have a quick tour about the biometric concept. Biometric concept, again, I'm telling you, it is not an old concept. Biometric concept, again, is a very old concept. Now you can understand that maybe 3 years ago, people use fingerprint to authenticate a document, so signature, right? Even today also we use the fingerprint image that is called the thumb X impression on a paper, right, to this one. Now what is the concept of fingerprint? Now fingerprint, that is a thumb impression, for example. If you consider this is a unique thing, and no two persons in this world, right, have the same fingerprint impression, right, it is there. Okay, so if no two person does not have the same fingerprint impression, then definitely it is a unique. So for every person, it is a unique. And then seeing, okay, your fingerprint impression and seeing other fingerprint impression, you will be able to see that the two fingerprint impression is different. Now, if I want to verify that whether this is the thumb impression yours, then what I can do is that I can take another thumb impression, I can check the matching. And the two, if it is matches, then I can say that, okay, it is right. So it's a primitive approach where we are using the fingerprint as a means for genuinity or authenticity. Now, anyway, so here the fingerprint impression, that is the thumb impression, it is actually a biometric concept. Now, what is the concept of biometric? A biometric is a physiological or a behavioral traits of a person. Now, for example, the fingerprint, it is a physiological trait. For example, your appearance, it is a physiological trait, right? The way you move, it is your trait, it is a physiological trait. Now, your iris is basically in your eye, there is a semilunar, circular one portion rather than the eyeball, and that is also physiological aspect. If I take a blood sample and from there if I collect a DNA is also a physiological aspect. Then your fingerprint or palm print or other, say, ear lobe or whatever it is, they are all physiological. So physiological means it is by means of physics that you are acquiring, and it is the one trait. And for every person, this physiological trait is different. For example, the face, you will be able to, even if they are twins, also you will be able to quickly distinguish between the two twins. So this is the physiological traits which we can consider for a person to identify that person. Now, other than physiological traits, there is another, it is called the behavioral traits. For example, my voice and the voice from Amitabh Bachchan. So definitely the two voices are different. So if you hear my voice and then Amitabh Bachchan voice, and then later on that two voices are given to you, you will be able to discriminate the two voices. So the voices are right, again, behavioral traits, because it is again some behavior that we can think, right, which can be used to distinguish the two persons. Now, like behavioral traits, there is a signature. For example, this is also another behavioral traits, and there may be many things also. Suppose you are pressing a keyboard on a computer, so key pressing is also varies from one person to another person. So key pressing on a keyboard also can be considered as a biometric traits, which is come under the behavioral traits. So there are many such biometric traits are there which can be considered to identify or to distinguish one person from other person. So there are huge number of biometric data, and people are considering the different biometric data to be applied to solve many problems. All those problems mainly been exercised so far for the person identification and person verification. As you know, you are using the face. Face can be used for identifying a person. So you can keep a record of a person's face, and then whenever a person comes, right, and then you can verify whether the same person whose record is with you or different persons are there. So this is called the identification. So identification is a one-to-one matching. So in your record, there is a one biometric data, and whenever you want to identify a person, then you will collect another data, so two can be matches. So it is the one-to-one, matching, it is called the person identification. On the other hand, verification. So verification, suppose you collect the fingerprint image and then you want to verify whose fingerprint image it is. Then definitely you have to verify many records and with whom it matches. Then we can say that it is there. So in a criminology, maybe in your Aadhaar enrollment, if you want to verify, then we use the person verification. So there also we can consider the biometric data to be used, whether you want to use as a physiological biometric trace or behavioral biometric trace depends on. Now in case of, for example, Aadhaar system, so we usually consider the face, fingerprint and iris are the three biometric tests, because these three biometric tests are very effective, very useful, very genuine to develop any identification and verification mechanism. That is why it is very popular among us. Anyway, so whether you want to use a biometric data for a person, it should satisfy three criteria. If they satisfy these three criteria, then only you can think that, okay, this is a valid biometric data that we can think for in my application. That these three criteria are called universality. That means if you want to consider a biometric data, then it should be available to all people. It is there. Now I can tell you one example which is not universal, so we cannot think about it is biometric data. Now consider, say suppose many people you know, they have 6 fingers. Many people have 6 fingers. Now if you say that, okay, palm print as a fingerprint consider, then definitely, so 5 finger usually the common, but some people may have 6 fingers also, then that is not a universal thing. So that is why we cannot consider this state as a biometric test line. On the other hand, uniqueness property. Uniqueness property, as I told you, a data should be considered which is unique, and then unique to a particular person. Now I am telling you, say hairstyle. Hairstyle cannot be considered as a unique data, unique physiological trait, because 2 persons may have the same hairstyle, or curliness of the hair, or thickness of the hair, or the density of the hair. All those things cannot be considered the biometric traits. And then the invariant. This is very important. Invariant means the biometric data that you want to use, it should be used not that for a short-term purpose. It should be used for a long-term purpose. So maybe that, okay, today you have collected the biometric data of a person, then you can be able to, you should be able to use it maybe after 10 years later or so. So time invariant is also an important property. That means, okay, so as the time varies, your biometric trait will remain invariant, will remain same. So that is the time invariant property. If all those 3 properties are satisfied, then only you can tell that this is the one data that I can collect from a particular person and then can be considered as a biometric data. So these are the 3 things are there, and then we can consider about it. Now, based on my discussion, we can think that there are few biometric data which can be considered that they satisfy all these 3 criteria. Now, I have given 6 different items here. You can understand that which 6 items can satisfy all those criteria and can be considered a better biometric data for your application. So you can just, okay, discuss it, do your arguments and then cross argument also. Then you can come to a conclusion that, okay, this is the biometric data which can be considered as a genuine biometric data. Now, in this respect, I just want to tell you, give an hint that face can be considered as a genuine biometric data because it satisfies all 3 criteria. Now, next item that is shown here, it is called the fingerprint image. It is also a genuine because it satisfies universality, uniqueness, and then invariant property. Now, this palm top, sometimes it is not. So, considering the 3 criteria, it is not so much unique. So, we may be a little bit, okay, careful about whenever you want to use this trait in your application. Now, the next is the 4th item. It is called the iris data. Iris data your iris image can be captured by a camera, very high resolution camera called the CCD camera, and then it will capture the texture pattern in your iris. Okay, so if this texture pattern is very difficult to differentiate with the naked eyes, but rather if you can process using a computer, you will be able to find the different textures that the different persons have. So this, okay, so these textures of an iris can be considered as a biometric data, and it is very a very efficient, very useful and popular one biometric data to be used there. Anyway, as I told you, in our Aadhaar system, we consider face, then fingerprint, and then iris, because these three biometric tests are really very useful to have it. But all these three tests have their own advantages as well as some disadvantages. If I find my time, or if you have any other questions related to these things also, I can clear these things there. Otherwise, we have to complete other important discussion. So I don't want to give much about the biometric data, right? Okay, anyway, so face, fingerprint, and iris, these are the three biometric data can be considered for any biometric-based application. Biometric-based application, as I said you, so long we have used those biometric-based application to person identification and verification. For example, in case of Aadhaar, we use it for the person verification. In banking system, we use these biometric data for person identification, like this one. Okay, but we are going to use this biometric data completely for the different perspective, which is a new and a novel perspective. It is called the perspective of cryptographic application. So biometric data, how can be applied to the cryptographic application? It is it will be discussed then. Now I was discussing about biometric data. Then you may be a little bit querying about that. What do we mean about the biometric data? Okay, so a fingerprint, this means that it is an image. A face, what it is a face? Face also we can think as an image. And then an iris, because it is captured by a camera, so it is also an image. So essentially, whatever the biometric data that we usually know or we usually use, it is an image form. Now, if this is an image form, then what are the different characteristics are there in the particular image so that I can use that characteristics to distinguish or discriminate one person to another. Now, so there are so many features are there. Now, if I say what is the features? Now, features are the characteristics by which you can distinguish. For example, given an apple and given an orange, you can distinguish the two fruits. How you can distinguish? Because they are differentiable in terms of color, in terms of texture, in terms of size, in terms of shape, in terms of weights, in terms of maybe smell, whatever it is there, right? So these are called features. So definitely these are the so many features: size, shape, color, texture, then weight, smell, all these are features. Now similarly, if we come into the biometric data, so every image corresponding to a particular biometric trait consists of many features are there. Now for an example, here if we see, this is a fingerprint image, right? In this fingerprint image, the features are called the bifurcation point. The features are called the edge point. For example, as you see here, the red color are called the edge point. That means one line terminated at that point. And then there is a blue color dots that I have used it here. They are called the bifurcation. That means one line bifurcated to two lines. So these are the red color dots and then blue color dots are the features here. That means they are called the minutiae features. So, and now if you see, if you minutely observe a fingerprint image, then you will be able to see there are so many lines are there in the image. And these lines either terminated at an end or bifurcate. So these are the point where a line terminates or bifurcated. It is called the features or minutiae points. So red color points or the blue color points in case of fingerprint image are the minutiae points. So these are the minutiae points can be considered as the features for a fingerprint image. Now even question is coming that how these can be used to discriminate. I'll come to that point discussion. Now likewise, face has the features. What is the distance between the two eyeballs? What is the size of the nose? What is the size of the face? What is the size of the lips? What is the distance between nose and lips? All those can be considered as features. Now whole the face image can be considered as a few or what is called the channeling points and then all the channeling points can be measured for a particular person, and use those distance measurement can be considered as a face features. And similarly for the iris feature, I have already told you that textures information is the features are there. Now, so these are the biometric features which will be able to use or can be considered so that we can distinguish one person to another person. Now I am telling you, now so far the face is concerned. So you can understand that, okay, if we consider two persons and then the distance between the two eyeballs, okay, it is different for the two persons. Similarly, from the forehead to cheek, the distance if you take, or the size, or the distance of the lips, whatever it is there, so they are the different. So all this data, if you can collect, store, then it will give you a biometric features. Now, so far the fingerprint image is concerned, as I said you, minutia points, each minutia point will be characterized by 3 data. They are called the position of this minutia point and then orientation of minutia point. What is the orientation? I can tell you the orientation here. For example, say this is the one minutia point. So if you draw the x coordinate and y coordinates here, sorry, okay, so if you, right, so here if you see, this is the line, right, and this is the angle made by, say, x direction. Now this is the orientation. This orientation is called the theta orientation of a minutia point. Now if you consider each point has its own orientation, as well as each point has the position. If we say this is the x and y direction and x direction, and what is the x coordinate and y coordinate is there. So minutia points can be characterized by 3 data. One is called the xy coordinates and then orientation, the theta. Now typically for a person, the number of minutia points in his or her fingerprint is varying from 40 to 65 minutia points are there. So we can consider minimum 40 points or maximum 60 points. Here for an example, for an image, we can capture 57 minutia points, for which we can take a note of the xy coordinates for each as well as orientation. So it is a 3-dimensional data. So 3-dimensional data, because 3 attributes are there, and then number of minutia points will be give you the total number of data that is possible for an image. For example, in this example, is that 57 data are there. So a fingerprint image therefore can be stored in the form of a tabular data. So we can therefore from image to a simple numerical data can be considered, which can represent a person's data. So this is the idea that biometric data can be captured and can be stored for the processing. Likewise, fingerprint and likewise face and then iris also can be stored there. There are many other mechanisms also. But in case of face, the number of features that we can think much more than the number of features that we can have in case of fingerprint. In case of iris, it is much more than the both fingerprint as well as face. And that is why iris is more robust, but it is computationally very expensive on biometric data. Now anyway, so these are the features that I wanted to discuss about it. Now let's come to the discussion about that these biometric data, how can be used so far crypto biometric system development is concerned. Idea is very simple. The idea is that, say suppose two communicating parties, sender and receiver. So sender has its own biometric data, let it be the fingerprint image. Maybe, okay, we can collect 10 fingerprint images, then more number of records are there, or even one fingerprint image, maybe middle finger's fingerprint image or thumb's fingerprint, whatever it is there, then only one fingerprint data can be considered, whatever it is there. So depending on complexity that you can afford, you can use it. Then every user has their own biometric data, and this biometric data will be utilized by your crypto biometric system so that from the biometric data of each person, we will be able to capture the features. And we can store in the form of a table, for example, in the case of fingerprint image, as I have said. So now this tabular data can be used to develop key. Key means cryptographic key. Now how this can be used to develop a cryptographic key, that is an interesting approach. I will discuss this approach in details. Now anyway, so this biometric data, for example, fingerprint image, can be used to generate cryptographic key. Now what I can tell in other words is that from the sender, I have a tabular data, and from the tabular data, I can apply some mechanism by which I can generate a key. This key is unique to this sender. Similarly, another unique key for a receiver also can be generated. Therefore, the two keys can be generated. Now, these two keys can be considered as a private key for each, and this private key can be utilized there. Now, again, public key can be generated using some synthetic fingerprint image. What is a synthetic fingerprint image? You can have some pictures and then pictures of a fingerprint image, and then that can be used, and then that you can share among the two parties, and then that can be used as a public key. So similar approach, but whether one is a real biometric data or a synthetic biometric data, that depends on, and by which we can able to develop both public key as well as private key, and then we can use them into the symmetric cryptographic key system. And this is the concept where we can generate a cryptographic key not using some random number generator or not using an hardware, rather using the biometric data from a person and then utilizing them into cybersecurity application. So this is the concept that is coming into the concept of crypto biometrics. So here cryptography is combined with the biometric, and then a cryptographic system can be developed, which is called CBS. Very popular term CBS, it is called the crypto biosystem. Okay, so we are going to discuss about how this biometric data can be used to generate a cryptographic key. That will be more interesting one topic to be discussed. It will take a little bit longer time. We have already taken almost 1 hour or so, and next 1 hour or so we will be able to clear this concept. Mainly two things that I'm going to cover. One is the biometric based approach to generate cryptography, and then its application to cybersecurity. Now, what are the steps that you have to follow in order to generate a cryptographic key given a biometric data? I will discuss this concept with an example, and in a particular with a specific biometric data. It is called the fingerprint data. Definitely these steps are different if the different traits are used, because all steps may not be the same. So these are the few steps which I have mentioned. It is particularly targeting the fingerprint data to be used as a biometric, right? So as you can see here, so far the fingerprint data is concerned. First of all, pre-processing is one important task that to be followed. Then followed by pre-processing, we have to follow the consistent region selection, and then the trellis diagram, convolution coding, and finally the key generation approach. Now these are the different milestones that needs to be followed, and we will learn about all these milestones, and then the rationale of the different approaches that we will, why we have to use it, I will also tell one by one. So let us start about, first of all, the pre-processing. Now in case of pre-processing, there are many tasks to be followed in order to correct a particular fingerprint image. The first task is called the alignment. Now whenever you capture a fingerprint of a person, you have to follow a biometric sensor. There is a low-cost sensor is available, and then it can just capture the thumb impression or any fingerprint impression of a person and can be stored in the form of an image. Now whenever you capture in an uncontrolled environment, then that captured image can be with the different orientation and the alignment. Now definitely if the alignment is not the same, then you can understand about that the different position of the minutia points also will be different. So alignment is therefore needs to be enforced very strictly. So there are many techniques, many approaches have been proposed in many literature for this alignment. There are some approach which will, now you are using machine learning approaches or deep learning approaches to align a particular image so that the exact alignment can be done, whatever be the raw alignment that is given to you. So it is again a very active research area till there is a scope of doing better alignment approach so that you can get the more accuracy or more success rate. So alignment is the one procedure by which we can perfectly align a particular image so that the minutia point information that can be obtained from each minutia is correct. So this is the alignments are there, and here is a main idea of the alignment. How we can do it? We have to first see that orientation of an image, and then how much we have to rotate the image so that the orientation can be perfectly make it as a vertical aligned or whatever it is there. So I have given two instances here so that alignment can be done in a ad hoc manner. Obviously, this method is not necessarily very accurate method, but it is a very simple method and very fast and simple method that you can follow it. Anyway, so there are many alignment methods. If you study different research, then you'll be able to find the different alignment methods. And if you are interested to align a fingerprint image, that is also very good research topic. Now, after the alignment, there is another challenges. So far, the dealing with fingerprint image is concerned. It is called the non-proper capturing of the image. So occasionally, we usually capture an image which is not a complete image, rather a partial image. So partial image means some part of the image, maybe front part or bottom part or left part or right part is captured only or missed other parts, whatever it is there. So this is also because whenever you collect a thumb impression or fingerprint impression for a person, he may not place this fingerprint on the sensor properly. As a result, we are not able to clear it. But anyway, so whenever you have to develop a system, then you have to make it robust, and then definitely it is not necessarily a controlled way of collecting the data, uncontrolled way. Then you have to do the partial, dealing with the partial image. So there are again many methods. So for the partial image, from the partial image, what are the regions that can be more specific to get it? And there is again many good body of research are available in this direction. And next is the enhancement. Enhancement means, say suppose a person for which you are collecting the thumbs impression, and at that time he or she was sweating or very much dry, then the image that can be captured may not be proper because there are a lot of noise will be introduced. That noise due to this sweating, noise due to this dust, or some other environmental issues may be there. Then so it is there. So in order to tackle this situation, what you have to do is that you have to enhance the image. So image enhancement, again, in image processing, there are many image enhancement techniques are there, which you have to apply to your captured fingerprint data to get the enhanced image. So these are the different pre-processing steps that I have discussed, which are the very common pre-processing steps. Now, there is another idea about consistent region selection. It is also part of a pre-processing step, but it is more than the pre-processing steps. What is the consistent region selection is that, okay, this image, assume that it is pre-processed, so far the alignment is concerned, so far the partial image rectification is concerned, and so far enhancement is concerned. All three processing tasks are done. Then you got better or more improved fingerprint image. Now, what is the next step that is required, and which is required to give the more accuracy or more robustness in your system? It is called the finding consistent region. Consistent region, the idea based on, say suppose you have developed one system which you can consider that which has used, say, 1,000 instances or 1,000 sessions of the different persons. Then you have the 1,000 what is called the data from the different sessions, and from you can analyze these 1,000 data, and then based on your analyze, you can decide that what should be the region of interest which is common so far this system is concerned. Now, as an example here in this figure, as I see, considering all 1,000 images, then it is an observation is that from the bottom, say T test, from the top, from the bottom B test, and from the top T test, and from the left side L test, and from the right side RS is the region which we can be which can be considered as a very insensitive so far the images or data is concerned. Then what we can do is that we can ignore this region. Now then, what is the region of interest? The region of interest excluding those portion, then what are the portion remaining is the region of interest. So here, for example, test, based, list, or RS, whatever, if we exclude it, and then focusing that particular region is the consistent region. And this region is a consistent region means whatever the images, whatever the way, whatever the sessions are there, if we limit our focus onto that region and then collect the minutia point, not the entire images, but only the particular portion of this image, then that portion of the the minutia point in that portion of the images will be more effective to use in your system. So this is the idea of the consistent region selection concept that you can think about it. And next is, another is that even in the consistent region is there, as I said you, typically for a person 40 to 65. And then based on this idea of the consistent region, we assume that 50% minutia point should not come into the scanner. So only 50. So maybe you can consider 25 on the average, for example, 25 minutia points have to be focused on. But processing 25 minutia points, definitely good. So far the variability is concerned, but processing time, if you see, it is also difficult, right, to afford. So what you can do is that for a faster application, we can think about limiting the number of minutia point into lesser number. Now, I can tell you one example. Nowadays, this fingerprint image is also being used in your mobile phone or smartphone. And then processing capability in the smartphone also very limited. So do you think that it's proper to consider all 50 minutia point to be considered for your verification? Then definitely it is not a good idea, because to check you, to verify you that, okay, you are the right user of this phone, then it will take much time. So in order to save that time, what you can do is that even in the consistent region, not the entire region, but only particular portion of the region, that we can think about it. Now this particular region, how we can do it, that we can think that how many or which portion in the consistent regions has the maximum number of minutia points which can be captured in almost all sessions. Then that portions can be considered as your ultimate portion. So it is a subsystem of the consistent region. So initially the whole image, then you limit your focus into the consistent region, then within the consistent region, you limit your target to the region of interest. So that will be the smaller number, and the idea is that smaller as well as accurate also, because this is the region where almost all fingerprint point will be always acceptable, right? And then usually number of minutia points that we can have so far a region of interest is concerned is usually 10 to 15. So initially 50 on the average, then 25, and then limiting this one into maybe 10 or 11, whatever it is there, will be your target minutia point that needs to be considered. Now, I hope you have understood about that, how the image can be processed, and then from the processed image, how the minutia can be extracted. Now we have, for example, say 7 minutia points are there in the region of interest. Now these 7 minutia points, therefore, will be our target minutia point. And from these 7 minutia point, we can extract the features. So definitely the table is smaller. So in that table, only 7 rows are there, 7 minutia points, and then 3 attributes values are there. So 7 into 3, total 21 data that needs to be used so far your application is concerned. So 21 numerical values you can tell representing a particular person's person. Represent a particular person. So this is the concept that so far the feature is concerned there. Now here I just want to go a little bit in details about, because our objective is to use these features or use this biometric data to generate cryptographic key. And then the next step towards this approach is, let us have more information about these biometric points. That means minutia points. Now consider 7 minutia points are there in your region of interest. Let they are M1, M2, M3, M4, M5, M6 and M7. Now what is our next processing? I'm telling you, our next processing is to calculate the distance from one minutia point to other. So you can see 7C2, the distances will be obtained from there, right? Now out of all those distances, we can sort all the distances in ascending order or descending order. Let it be in ascending order. The smallest distance first, then the next smallest distance, and then the last distance, and this way. Now, after the ascending order of all the distance, say suppose these are the distances that we can have it. So what is the step? Our step is first consistent region selection. Then we have to select the region of interest. In the region of interest, only consider the 7 minutia points. Then out of the 7 minutia points, calculate the distances among all the 7 minutia points and arrange them in an order, ascending order. They are, for example, D2, 3 is the smallest distance between the minutia point 2 to 3, and the next is the minutia point distance between the minutia 3 to minutia point 4, and so on. So this way, we will be able to get 7 distances so far the minutia points are there. Now, after this or arrangement is concerned, we will be able to tell that, okay, the first minutia point, which in the smallest distance will be the first elements, and so on. So this will give you a unique ordering of all the minutia points which you can extract from a region of interest. Now, I hope you have understood what is the rationale of this approach. The rationale of this approach is that from the minutia point, region of interest, we have 7 minutia points. Then their ordering is also important. So we can impose an ordering following a particular rule. So this is the rule that I can tell, and this rule we can have, and then we can get it. So this is the one rule that we have done the research on it. You can find another better rule which can give better result also. So this is also give you another research opening for you also. Anyway, so this is the idea. Idea is that region of interest, from the region of interest, get the minutia point, and then a unique ordering of all the minutia points should be considered. So what we can do is that, given an image, all the rows that should be there in the table should be in a particular order, not that in any order. Which minutia point will be top, which minutia point is the bottom, that is now resolved. Okay, so this table is, we can say, an order table that we can obtain based on this method. Now our next idea is that, okay, we can summarize the concept is that from the given image, do the pre-processing, improved image can be obtained, then find a consistent region selection, and then out of this consistent region selection, you can find the region of interest, and then region of interest, from the region of interest, you will be able to get some selected minutia points, and from the selected minutia point, you can have a unique ordering of the points. So this part I hope you have understood clearly. The next part is that how we can use this unique ordering of the minutia points towards the generation of our ultimate target, that is the cryptographic key. Now this is again well researched one agenda, the idea that we are going to discuss about it. So the concept that we have used, it is called the trellis diagram. Trellis diagram is a cryptographic format. It is a cryptographic paradigm which is used in many cryptographic applications. Trellis diagram, it is a unique diagram. It is a unique picture right, from a given image which we can obtain it. Now here from the fingerprint image, we are in the process of developing another Taylor's diagram, but Taylor's diagram where we want to take the minutia points as the picture element. And as you know, from the fingerprint image, we have only 7 minutia point, that is to in a particular arrangement. And then we want to see that how this particular arrangement can be converted into a Taylor's diagram. Now, in order to in order to obtain a Taylor's diagram from a given set of minutia point, our objective is to create a new concept which is called the definition of a state of a minutia point. Again, I am telling you, see, I told you for each minutia point there are three data: x coordinate, y coordinate, and then theta coordinates, right? Theta data. Theta means orientation. Now we will consider now only so x and y coordinates have been used in order to have a unique arrangement of the minutia point. So that data have been used, right? Now next is that what is the utility of the theta, that means orientation of a minutia point. Now we can divide the orientation of a minutia point into 4 states. If the orientation is in between 0 and 90 degree, both inclusive, then we can say it is in state 1. Then if it is in between 91 to 180 degree, both inclusive, then we can say it is in state 2, and so on. So depending on the orientation of a minutia point can be either in state 1 or state 2, state 3 or state 4. So state 1 is in a first quadrant, state 2 is second, then third or fourth quadrant. So this way we can distinguish a minutia point in which state. We can represent these 4 states as a 0, 0, 0, 1, 0 and 1, 1. So it is a binary representation of the state, you can say. Now what we have here, so we have 7 minutia points in a particular arrangement, which it is like this: M2, M3, M1, M4, M6, M5, M7. Our next target is to find the state of each minutia point depending on their orientation. So now let us consider the first minutia point M2 is in state 1, then M3 is in state 3, the M1 in state 2, and so on, so on. So we will be able to identify for each minutia point in which each points, in which state each points is. So this way we will be able to find the state of this minutia point. Next thing that we have to do is the diagram. So this diagram is state change. Now here this concept can be expressed by using one coding mechanism. It is called the convolution coding mechanism. As you see here in this figure, the minutia point M2 is in state 0, 0. Then minutia point M3 is in state 1, 0. Then there is a transition from state 0 to state 1, 0. Now how this transition can be enforced? That okay, it is from this minutia from state X to state Y. How we can do that? In order to make a discrimination of the state change, we can follow one simple coding system, and that coding system is called convolutional coding. So if you know about error correction in message, in text communication, there we use one concept. It is called the convolution concept. So in case of convolution concept, one simple architecture is followed. It is called the convolutional coder, which will be developed by using 2 flip-flops, and each flip-flop will take an input 0 or 1, and then they can change the state. So you know a flip-flop can change its state depending on the input that it bombarded on it, and then accordingly it will give the 2 state. So here for an input, it will decide what will be the next state given a present state. So it is just like a state transition diagram. And in this figure, if you note it little bit carefully, so this is the convolutional coder, and according to this convolutional coder, this is the state transition. That means this coding system can changes from a any one state to any other states out of 4 different states are there. So 4 states like 0, 0. So in this, for example, in 0, 0, if 0 is input, then it will be remain in the 0, 0 state. On the other hand, if it is 1 is input, then it will move to the 1, 0 state. So again 1, 0 to either 0 or 1, depending on it will change its states. So this is the state transition diagram, it is there. Now in addition to this input and then state change, there is also an output concept is there. For example, if a system is in state 0, and then if it receives an input 0, 0, 0, if a system is in state 0, 0, and if it gets an input 0, then it will remain in the same state but producing an output 0, 0. So this is the output that can be obtained from the conditional coding, it is there. So this is the digital circuits, simple, right? Synchronous circuit we can tell, and according to this synchronous circuit, different input, and then depending on the present state, what should be the next state, along with what is the outcome that this coder will return, it is there. So this is the diagram that you can think about it. Now we will use this state transition diagram followed according to a conventional coder to decide what will be the state change. So far our minutia pattern is concerned, and then it is in the trellis diagram. So here is the idea about it. You can again check it. How you can get is the state change information, and accordingly the trellis diagram can be completed. Now here, for example, this minutia point M2 is initially in state 0, 0. Okay, and then here, so it is a state 0, 0. Okay, and the state 1, 0. Here, for example, the minutia point M3 is in state 1, 0. So state 1, 0. So there is a state change from 0, 0 to 1, 0. We can like this, right? And from here again 1, 0 to M1, which is in the state 0, 1, this way is there. Now here, whenever these minutia points in between the M2 and M3, two neighboring minutia point, right, and their state change, we can decide what will be the output that we can obtain it. So it is in state 0, 0, and it changes to state 1, 0. For example, 0, 0 to 1, 0. So it produces the output 1, 1. So we can take the output 1, 1. So this way, the different output that can be obtained according to this trellis diagram that we have. Now these outputs, it is a 2 bits output for each state change that can be noted here, and this will give a pattern. For example, according to these 7 minutia points and their states, and following the state changes and then the conventional coding application, we see a unique pattern that can be obtained, which is 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 0, 0. So for 7 minutia points, 7 into 2 bits, so 14 bit pattern that can be obtained. And this 14 bit pattern is unique for a unique fingerprint. Right? Given a fingerprint, this is the pattern that we can obtain. Now this pattern can be considered as a unique arrangement, or rather we can say it is a key, or it is a cryptographic key, or is a binary bit pattern. So definitely it is a 14 bits. But you know, we need more bit patterns. As I said, minimum say 256 bits should be considered for cryptographic key. Then the question that arises is that how we can have more longer bit pattern so that we can generate a longer keys. Now here is the idea about it. The idea is that we can have more patterns can be created from the set of minutiae that we can extract from a region of interest. As an example, for example, say only 4 minutia point for an example consider. So M2, M4, M3, M1, this is a unique arrangement of the 4 minutia point can be extracted from a fingerprint image. And this is the initial pattern, M2, M4, M3, M1, and accordingly trellis diagram can be obtained. And for this there, we can have the 8 bit pattern that can be generated because 4 state changes are there, so 8 bit pattern can be. So if we consider MS set only, so a bit pattern of size 8 can be obtained. Now we can have many other what is called the arrangement of the bits. For example, out of these 4, taking 3 at a time, we can have so many arrangement. So 4p3 arrangements are there. Now 4p3 arrangements, if we consider, they will give another bit pattern for each arrangement. For example, MT, M4, M3, then M2, M4, M1, and so on, so on. So this way, for 3 arrangement and then 4p3, so 3 into 4p3 into 2, so many bit pattern can be obtained taking from MA only. Now again, we can take some other arrangement also within the same arrangement. For example, changing only the first 2 minutia points. Here, for example, M2, M4 can be swapped between the two. So M4, M2, M3. And then this swapping can give you another arrangement, and then another bit pattern can be obtained. So we just organize many arrangements of getting a fewer minutia point patterns, and then large bit pattern can be generated. And this way, we will be able to get whether it is a 256 or 512 bit or 1024 bits, no issue. So this is the idea about that. Okay, long and very large bit pattern that can be generated from a given fingerprint image, even starting with the 10 to 15 minutia points are there. So we will be comfortably able to generate very large bit pattern from the set of minutia points. So in summary, what we can do is that for each set of minutia arrangements, we will be able to find a bit pattern. And this bit pattern is a binary bits. We can easily convert in the decimal form. Because usually in cryptography, the binary bit pattern, instead of using the binary bit pattern, we can convert this binary bit pattern into a very large decimal numbers. So, for example, from a 8-bit bit pattern, we can generate a decimal number. Similarly, if it is a 256-bit pattern, we can generate a very large decimal number, and then we can do it. So, a very large decimal number can be obtained. So, for example, the different pattern that we have considered, MA, MB, MC, MD, we will be able to consider many, 4 different decimal numbers we can generate for each pattern like. And then for this bit pattern, what we'll be able to do it, we will be able to generate a key, because our objective is also other objective is to be, I'll tell you what is the another objective is there. Anyway, our ultimate objective is to how the random pattern in a fingerprint image of a person can be exploited to build a unique number, a unique decimal number, you can say. So we can do it by means of this conventional coding using the Taylor's diagram for it, and then we can do it. So this is the unique number generation is there. Now, these are the different 4 numbers which we can have from the 4 different patterns, can be mathematically structured into the different other values to be obtained. For example, say suppose from the first pattern we obtain a decimal value GA. From the second pattern we obtain another value GB. Then we can obtain another numbers GA to the power GB, or vice versa, whatever it is there. So it is up to you which mathematical structure you want to use it to get a new number from another set of numbers. So it is the concept. For example, R and S, 2 different numbers can be generated using 2 different mathematical structures. And from these 2 numbers, another number can be generated with some another mathematical structure like RS mod P. You can understand why we are doing so. You can recall, in order to build a key, it should follow a non-linearity in the function. So here you can see we are following some non-linear transformation of the values that we can obtain from the initial fingerprint, and then their initial numbers that we can generate from them. So this way, if we do the non-linearity, then a more stronger key can be generated. So this is the approach. And another thing is that revocability. For example, suppose it is always obvious that, and essential also, that you should not use the same password for a longer time. you should change the password occasionally or frequently, whatever it is there. So if you want to change your key, how you can do it? Now you note that from a given fingerprint data, you can obtain only once the key values generate, only one key can be generated. Whatever the GA, GB, GC, GD is a one time write only, and this is the permanent one. Because you cannot change this GA, GB, GCD value, right? Because the fingerprint image is a permanent and static things are there. It cannot be changed. Okay, so this is fixed. But from this fixed composition, how we can have a dynamic composition? If we have some dynamic composition, then it will lead to a revocability. That means if you want to change the key, then you have to follow some different mathematical structure so that it is there. For example, R can be obtained instead of GA to the power GB, rather GA plus GB to the power GC, or these kind of things. Then definitely the new numbers, so instead of K, it will give you K dash. So this way you can easily, just changing the mathematical structure, you will be able to generate a dynamic key. So key can be changes dynamically and depending on your requirement, and this is the revocability. So this is the key generation concept and then revocability issue, which is essential so far cryptographic key generation is concerned. Now you note, we mentioned the three criteria. One is strong. I hope you can guess that how strong key can be generated. And another is long also. I told you according to the proposed idea, how the long key can be generated. Even you can generate a small key as well as long key depending on your how you want to change the arrangement of the different minutiae points are there. So even starting with 10 to 15 minutiae point, you'll be able to generate 512 bits key or 1024 or 2048 bits key. Absolutely not an issue. And second is randomness. Randomness can be obtained because randomness is an inherent capability so far the fingerprint arrangement is concerned or minutiae point arrangement is concerned. So the appearance of the minutiae point in a fingerprint itself is random, and therefore the randomness property can be obtained automatically. In addition to that, the revocability and the nonlinearity also can be introduced, and this way, this approach which we have discussed is a better approach so far the cryptographic key generation is concerned. In addition to that, it also has few more additional advantages compared to the existing, whatever the PRNG based approaches are known till date. First is that enrollment. All the previous approaches that is known to us, the existing approaches, they are based on enrollment. That means once you generate a cryptographic key, you need to store somewhere. Because if you don't store it somewhere, later on if you want to get the same thing, for example, you have encrypt using a cryptographic key and later on you want to decrypt it. So unless if you store this previous key, then you will not be able to go for decryption step. So you have to store it there. And storing a cryptographic key in some place, whether in your local machine or in a remote server under the custody of third party, right, whatever it is there, it is definitely not necessarily guaranteed to be a secure one approach, right? Nobody can give you the guarantee because if you store your cryptographic key in your computer, you can understand that how much secure so far your storing thing is concerned. But similarly, if you store in third party, it is up to the third party regime that how secure your keys are there. So if we make a system which is enrollment fee, then definitely it is better so far the security, robustness in the security or reliability in the security is concerned. Now here, we don't have to store because it is inherently in your finger and then you don't have to store it. Whenever you want to generate a cryptographic key, only you just get capture your fingerprint image and then pass it to the system. System will do the procedure which I have mentioned, and then key can be generated. So no need to store the data anywhere. Another is the user friendly. If you don't store, then you should remember, or you can use some other device like smart car or mobile phone or whatever it is there. And as you don't have to remember it, no need to store here, it is more user friendly. And it is obviously user friendly because we don't have to bother about anything else. Only you know that, okay, my fingerprint is with me only. But obviously, if there is an accident and then your fingerprint become damaged or any other deformed, then definitely this system will not be more applicable. But in that case, another provision is there. The provision is that instead of only one finger, you can consider 5 fingers or 10 fingers. So it will give you more at least 10 times reliability than the one finger based approach. So this way you can avoid it. But if the whole hand is amputated or something like, then definitely or 2 hands is amputated, definitely this system is no more available so far the fingerprint biometric data is concerned. Then in that case you can think some other biometric data, maybe face or also. So there are so for every problem, for every issue, we can address those issues and then find a new solution or some alternative solutions are there. Anyway, so biometric based approach to generate cryptographic key, which we call BioKey actually, and it is more user friendly than any other approaches are there. And obviously this method is reliable because we have tested, rigorous testing, both formal as and informal testing have been carried out, and it is observed that it is robust against many attacks. Right, there is many security attacks are there, and we have checked that with reference to each attack whether your biometric key is robust or not. We have checked that it passes almost overcome to all attacks are there. And random because it is inherent, BioKey is unique for each user, and this way, so we will be able to generate so many random keys, so many population in our world is concerned. So that is fine for every user, a unique random key, unique BioKey, and number of BioKeys are there, say that also according to the number of total populations in this world is there. So randomness is, you understand, if it is not infinite, it is huge. So these are the very good points so far, this novel approach, the advanced approach of BioKey generation is concerned. I hope you have understood the concept that crypto biosystem, and in this crypto biosystem, how fingerprint image can be used to generate a cryptographic key, and then this cryptographic key can be used in many applications. There are cryptographic application, we can say the cyber security application. Many cyber security applications can be developed based on the BioKey that we have developed it. I'll tell you the cyber security applications like user authentication, the network security, data storage security, remote authentication, and many more others are there. So let us have some idea about that, how this BioKey can be utilized so far the user authentication is concerned, and how this user authentication based idea it is there. Now, so user authentication is used for login and password. You know, login password, there may be some alphanumeric string can be used for that purpose. And there is also another idea about question answer, right? Some question and some answer based approach also can be used for to check the authenticity of a user. So these are the different methods we know. Other than this login, password, and question answer based method, the smart card also can be used. So you have to use the smart card. And recently, many people are using mobile OTP for the authentication check. When there are some banking transactions or any online transactions, there is, OTP is used. So mobile OTP is also used for user authentication. And then third-party services. Third-party services means you have to enroll yourself into a third-party service. And then whenever you want to authenticate, you can just present yourself. Maybe that presentation by means of login password or smart card or any other means, question answer also may be there. And then third-party service will generate a key for you. And that can be used for your authentication checking, so that third-party service to actual resource that we want to use, that can be passed there. So this is the approach. And then finally, the biometric-based approach. Now, so these are the four different, right? Four different ways by user authentication can be done. But each approach has their own problem. So login, password, question and answer, you can understand. So far the attack is concerned, login password is susceptible to a dictionary attack. Question and answer, again, it is not user friendly. If you forget a particular question or what is the answer corresponding to the question, then definitely you will be restricted to use that system. So login password or question and answer, it is not guaranteed to be give you foolproof one system. Next, come to the smart card and then mobile OTP. Now, smart card, fine, it is good, but it is susceptible to theft. I mean, if it is stolen, right, then definitely it is useless forever. Then mobile OTP also, if your mobile is captured by someone, then your mobile OTP can be accessible to other people also. And therefore, smart card or mobile OTP is also not a foolproof system. Now, third-party service, it is good, but again, it depends on how genuine, how reliable, how authentic your third party is there. Nobody can guarantee, or nobody can trust any other, in fact, in this world of untrustworthiness. So third party service also have that kind of problems. So if you use a trustworthy third party service, then fine, you can feel secure. Otherwise, it is also not 100% secure. Next is the biometric. Yes. So if we consider all these things are there, so as I already mentioned that, no enrollment, nothing to be remembered, user friendly, there is no concept that it will be stolen by one or damaged by others or whatever it is there. So in that sense, biometric based one idea can be used. So biometric data can be used for your authentication checking, whether the Gmail account opening or accessing any other remote resources or any other resources or any other things it is there. So biometric data can be used for that purpose. And then user authentication, if you want to implement any user authentication in any cyber secure application, so best idea that biometric data can be considered and then you can use it. The next cyber security application is network security. So the idea is that you want to share a message. A sender wants to share a message to a receiver, and then this message sharing is to be done through an insecure channel. Now, there may be intruder or man in the middle attack is possible because the channel is insecure. Anybody can trap the channel, get the data, and then, either they can damage the data or then change the data, so it will, the problem, so far the integrity is concerned. And then the data which you want to authorize to a particular receiver, it cannot be more authorized, so authentication also will fail. So in case of network security, the two things have to be mentioned. One is the authentication property and then integrity property. Now here, what is the idea is? The idea is that sender wants to send a message to a receiver, then definitely this message transmission can be done through, the encryption and decryption procedure. Now, if you want to do some encryption and decryption, then some cryptographic formalism that you have to follow. And if you want to do it, then you should follow cryptographic keys are there. So here the idea is that cryptographic key can be developed based on the bio key from a biometric image, maybe fingerprint or face or iris or whatever it is there. And this biometric key can be used for your encryption purpose and decryption purpose. And if you follow asymmetric key, then both sender and receiver can use this key of their own, and then following a message, what is called that key exchange protocol, like say Diffie-Hellman or RSA protocol or DSA protocol. There are many protocols are there. Even the elliptic cryptography also can be considered, where also you need to have certain keys, and then you can use it and then you can have it. So the network security based application better can be developed using this biometric based cryptographic key. So we have published one paper in this regard. If you are interested to know how the network security using BioKey can be developed, which you can find in the Eurasiv Journal on Information Security. It is a Springer. The title of the work is Fingerprint-Based Crypto Biometric System for Network Security, which has been published in 2015. I will not be able to discuss the detailed mechanism about how this network security can be enforced using CBS, that means Crypto Bio System. Okay, the interested the participant can get this paper from the net and then can study it. And then they can also, because this is a research, new research, and so from this research, if you can find many other modification or improvement, then it will mature the research direction also. So there is a scope of more research work it is there. So far the cyber security application, namely network security, is concerned. Next is data storage security. So data storage security, for example, you want to keep your data, for example, your doc file. So you can make the doc file as a password protected, whether it is a doc file or PDF file. We usually use that DOP, document opening password. So you have to give a document opening password, and then the document can be encrypted. And then again, in order to open the document, so the same document opening password to be supplied so that the document can be opened. Now in this process, if you forget, suppose you forget about DOP, document opening password, or suppose you install a new version of the Word or PDF, then the older version cannot accept the previous method of creating the encryption or decryption of your document. Then the problem is that you will lost your document. And if your document is very valuable, then losing a valuable document is also not desirable. So what is the best idea that the data storage security can be here? I am giving an example here. For example, say document, storing a document in a secure manner. Then here, for the document opening password, which you use maybe a string of alphanumeric characters, instead of that, you can use your fingerprint image. That can be there. Nowadays, the computer is equipped with fingerprint sensors. The camera is there, okay? Even the webcam also very, sufficient to capture the fingerprint image. And then we can generate the key, and then that key can be used to encrypt the document or decrypt the document. So the good point is that if you forget, there is no question of forgetting the things it is there. So your document will be secure. Only you will be able to open document, nobody can, and therefore the highest level security that can be obtained. Now further, the data storage security also can be enforced among the multiple parties. I will discuss this concept later on as a multi-party security concept. And then also in a remote location, if you want to keep a document under the custody of a third party, that also you can do, right? You can encrypt the document with your cryptographic key generated from a biometric trait and then keep it there. So it is trusted then, because third party will not be able to access your document because they don't have your biometric data with them, and therefore it is secure. So whether in a remote location, if you want to keep a data secure, even in your own PC also, if you want to keep the data secure, then you can use the CBS system to make the security, and then you will get the 100% security process is there. So this is the data storage security is there. Now related to the data storage security, one of our recent research published in the year 2017 in Multimedia Tools and Applications Springer, volume 78, issue 19. The title is Biometric Based Cryptographic for Digital Content Protection Without Any Key Storage. So here many other important information, the detailed description about how the data storage security can be enforced, you can get it. And this is the initial research, and definitely there is a more scope of research to advancing this concept, right? And if you are interested, then please, read the paper and then see whether you can contribute in this direction. So this is the data storage security. Now next is the remote authentication. Nowadays, we are solely connected with the network, and your resource, this may be hardware resource, this may be an application software resource, or maybe any data, whatever it is there, usually stored in a remote location. And whenever some remote access is required, then for the remote access, authentication also to be enforced, because the resource which is granted to you, right, then it should be accessible to you only, because you are the only authorized person to access your resource, no one else. So the remote authentication, it is there. So what is the general idea of the remote authentication? Suppose you user as a client, you want to access from a resource server, say RS. So she want to get some resource from the RS. Now, before granting a resource, what exactly the client should do is that client should approach to an authentication server, which is a remote server, which is located in a internet location maybe. So the client should send an authentication request, sending some credential. That credential may be login password or mobile OTP or smart card, and the latest is the biometric impression. Then authentication server will process this request and then will verify the client's credentials, and then they will generate some response to that. It is called the ticket. And then this is actually the ticket is the granting permission. So ticket granting permission, we can say it is. So a ticket will be issued to the client when the client passes its authentication successfully. Now this ticket will be used to place a service request to the resource server, and then if this ticket is genuine, because the resource server should know whether this ticket is from the genuine or not, and then if it is a genuine ticket, then the resource will be served to the client. So this is the idea about remote authentication mechanism, which we usually follow in our cyber security application. Now, in this context, many the remote authentication protocol have been developed, devised. Few important, here we have mentioned three important remote authentication protocol. One is called the OpenID, OAuth, and another is called the Kerberos. Now, out of these, Kerberos is the very popular, and till it is used among the many applications. In many applications, Kerberos protocol is being used for the remote authentication. Now, so here we can build, but Kerberos authentication is also not free from limitation. It also suffers from issues. Many limitations are there. So addressing all those limitations, a new approach of remote authentication using CBS, that is a crypto biometric system, can be also developed. We have developed one, that kind of remote authentication system, which we have published in 2020, which is designing secure and efficient biometric-based secure access mechanism for cloud services. If you are interested, then you can read this paper, and this paper is published in IEEE Transactions on Cloud Computing. And so this is a recent work, and there also you can find how the remote authentication using CBS can be developed. So we have done some work, but again, there is a scope of more work also. So if you study and interested, then definitely I should encourage you to encourage to work in this area. So these are the few areas that I have told you. The area is called network security, data storage security, user authentication, and remote authentication. Now, another application of our CBS, it is a single user authentication, because in case of single user authentication in your either PC or in any other system or in any e-bidding application or in online portal like Amazon or Flipkart or wherever it is there. So you need, to keep yourself more private to the access, then you need one key. That key, usually you use login password. Instead of login password, the separate key that can be used as a CBS-based, biometric-based cryptographic key, so that you can use it. So this is a single user authentication. And interestingly, the same we can extend to the multi-party authentication. So the idea of the multi-party authentication is that there is a resource, and this resource should be kept secret using a key, and then lock system is there. Now the idea is that, so multi-party authentication means one lock is there, but this lock should be opened by multiple users. Then one idea is that, okay, the key of this lock can be shared, but this is again problem, because the problem is that if suppose one user is removed from the system, from this group, then we have to change the keys for all other remaining group members. But this is not desirable because it is a costly affair. So similarly, if a new members are joined, then whatever it is there, again you have to change these new keys. Or maybe suppose you want to change the key or change the lock, then you have to change the everything for all members. So whenever the multiple keys are involved in multi-party authentication, that means if a shared resource are to be used by more than one user, then it is called the multi-party authentication. This application has many, for example, e-bidding application. So e-bidding system can be accessed by more members in a group or a certain members in a group. Then if it is like this, then how that multi-party authentication can be ensured? So in case of multiple authentication, multiple keys are there, and all multiple keys should be private. And whenever the private keys are there, then definitely CBS is the best candidate to implement this one. So using the CBS, what you can do is that for multiple users, the multiple keys, and it is all multiple keys are the private. And then inclusion, expulsion, and revocation. That means if a new member wants to add it, it will not affect the existing members so far their own private keys are concerned. A new member will join to this system with its own private key, and there definitely we have to make certain security formalism how it can be done. And that security formalism you can think for how you can do, so that a new member, if it joins, then what you should do that in addition to k out of n members, for example, or specific k out of n members, key can be used to access, any member can access in presence of k out of n members or k specific out of n members, so that it can be there. So you have to think about a protocol, then policy needs to be discussed. We are recently working on this. If a new member is added or a new member is removed from this system, or if a member changes its private key, then how the multiple users can be allowed to access a common resources, and then what formalism can be done there. So we are working in this direction. It's a very challenging one work. Many and a new work, of course, totally new works. And then one project is going on. An idea I have given it, but this is a very the very rough idea, abstract idea. I don't think that we will be able to discuss in details because it is not possible. Anyway, so the main thing behind this idea is the key generation and private key generation, and then private key generation based on biometric. Now I have discussed an approach that how the private key can be generated, bio key can be generated using fingerprint. Similarly, the research can be further extended considering other biometric data, for example, face, or maybe considering iris also. And then one more future direction is that multimodal key generation. That means more than one mode of biometric data can be considered. On not only fingerprint, you can consider fingerprint and face, or fingerprint and iris, or both fingerprint, face, and iris. So if you can consider multiple mode, from each mode you can generate key, and then combining multiple keys together, a better key can be generated. This key is very secure. Nobody can tamper it. Nobody can access it. So definitely, if it is a very critical security needs to be enforced, then the multimodal key generation is the one approach that you can think to generate this one. So this is another active area of research, and then we are working in this direction. You are also most welcome to work in this direction. Okay, so this is my submission for today. I think I have taken much time. So it is time to take some questions from all of you. So if you have some questions, then it is better. Fine, I can take some question. So let me, okay, so yeah, I'm stop presenting now. Yes, so if you have any question, please tell. Definitely, if you are new to this security area, then all those things is little bit okay, appear to be cryptic anyway. But this is the concept. Security field itself is a very only few people can adventure into this because it is too difficult and then it's more mathematically decode and many intelligent approach to be devised so that you can survive with the security requirement. Okay, fine. So any question, please? I don't know whether you are able to follow my delivery or not. Yes, good. If you can type your question in the chat box so that I can open my chat board and then I can see it there. Yeah, so okay, first question is, it is from Sri Lakshmi. What different biometrics can be used other than fingerprint and iris? I already told you, different biometric means even you can consider DNA is another very advanced biometric for your purpose. Okay, so we have already known that how fingerprint and iris, so face also there, and DNA, and then palm print. Palm print means, you know, the fingerprint print. These are the physiological biometric. There are many other behavioral biometric also you can think about. People are using, like say, keystroke space, right? You are using computer and then the computer can log your keystroke space and then get it. Now, many people are also fond of using speech as a biometric data. This is also another behavioral characteristic that you can think about it. So there are many, okay, so not necessarily, but so far the technology is concerned, processing of fingerprint, processing of iris, and processing of face is very popular. Many already established method. For example, if you want to use fingerprint or iris, you have to follow many pre-processing steps. Now, there is a very robust and improved pre-processing techniques are there. So you don't have to fight again other pre-processing, because at the very beginning, if your pre-processing step itself is a faulty, then the rest of the things will become unreliable. So that is there. So it is better to work with whatever the standard biometrics the data are there. So if you want to adventure with some new biometric data, definitely you can think for DNA or speech data for that. But rather, okay, you can think about, so far CBS is concerned, those are the standard biometric which are available to till time. Okay, so this is the question that from Lakshmi. Yes, Gayatri, I understand that, but you like it. Thank you very much. So that I made the discussion very simple, only giving an abstract idea, not technical details. And for the technical details, I have already give the reference of our recent published work, so you can go to that. Yeah, so Vishal, you just, how can we reach to you? Okay, fine, I'm always accessible. You can, okay, take my email address, I'm typing, right? So if you have any, right, okay, if I can help you in any, okay, way, that will be my privilege, so fine. I have already typed my email ID, so you can, okay, feel free to approach to me. Yes, so that's fine. So which sensor can be used for keystroke for IoT? That's a good question. There is no extra sensor to be followed there. Keystroke can be sensed by your machine itself, but you have to do this in a little bit in a system level programming. Okay, because whatever the key press are there, for each key press, there may be some sensors are available in usually, for example, MacBook or in Apple system, whenever you press a key and many sensors are there which sense you sensing, I mean, pressure, maybe vibration or other right tactile things are there, it can check it. It is being used for the developing many application for the other category of people with special need, for example, blind people or physically disabled people or this one. So they are using that kind of sensor are there. So the existing the existing computer also can be there, right? But you have to do little bit system level programming for that purpose. But a specific sensors you can incorporate underneath of each key, and then it can be used for there. So there definitely you have to use some Raspberry protocol or some other processor to be included for that, and then sensor to be added there. So little bit hardware extension to be done in your keyboard only, and then the data can be collected. So that hardware expertise is required for that purpose. So any sensor you can use, but depending on what sort of sensor, whether the pressure sensor or vibration sensor or any heat sensor or temperature sensor, that you can use it. And then all these sensors can sense it, and then those sensing input can be processed using any the processor. So in IoT it is available, and then you can get it. Yes, one question from Sunil Sharma. Sunil, your question is, using DNA and fingerprint, this possible to get same fingerprint of 2 or more person? No, it is not like that. That is what I am telling you. So we have not seen any matches that fingerprint from the 2 different person giving the same cryptographic key. We have tested with many data collected that is available from the different benchmark data. It is available. The face database, there is a huge set of face database, fingerprint database is available. Face data set also available. And then many iris data is also available. So we have tested with the noisy data as well as the data from the different persons from different regions, and so many things are there. So adequate research have been carried out, and then it is observed that even the DNA also, DNA is unique. It is proven fact. There is no more proof is required, and fingerprint like DNA is also unique. So hardly there will be no chance of matching. But only thing is that if some fingerprint, because of the noise and others, you may not get 100% accuracy. But whatever the recent results say that the accuracy is obviously not 100%, 99.9% or 99.99%, but still 0.1 or 0.01% failure is there. This failure is not that the match similarity match failure. This failure is because the noise related issues are there which you will not be able to overcome. So those things are there. Okay, fine. Thank you for your question. So there is another question from Prakash Meena. Is there any noise issue in biometric detection? Yeah, definitely. That is what is very, very challenging problem. Noise is a really very critical issue. So far, the robust CBS system development is concerned. That is why you can note that for the fingerprint image processing, I have discussed pre-processing step, right? Alignment, partial image capturing, and then dealing with noise so that enhancement is there. And then for every pre-processing step itself is a huge research work it is there, because to deal with the noise. So 99.99% accuracy, it is possible only if your system, is a noise immune system or noise-free system. So in order to get rid of noise, then you have to, noise removal method you have to follow. And then noise removal method for different biometric is a different techniques. For example, iris, the different technique, right? It is totally texture related. So Gabor energy feature or some DCT transformation or wavelet transformation, all those things are noise immune system that needs to be developed. So these are different. So biometric, that is why it is exactly not a single discipline, multiple discipline, where the electrical, electronics, and then computer scientists should merge together to build system. Because so these image processing tasks, because all biometric data, they are image sensitive data. Even the DNA is also this kind of data. You can think about it that okay. So sequences there where the computational intelligence needs to be followed, AI, machine learning have to be applied. So many things are there. So noise is a very challenging situation, and then we have to overcome to do this. And then many signal processing expertise is required. Okay, fine.
So if no other queries, I thank Samantha sir for sparing his valuable time with us and giving us a lot of insights on this biometrics. Thank you very much, sir. It was really a wonderful session, and hope all the participants have got benefited out of this. Thank you very much, sir. Thank you, sir.
Okay, thank you. Thank you all. Stay safe. Wish you all the best. Bye then. Okay?
Thank you, sir.
Okay. Okay.
So we'll